transformer, okay, to supply to a commercial building. Okay, so the distribution transformer is rated 310 kVA. The current maximum demand is 250. So it has, we want to check actually. We want to check whether we can get connection, get supply from that existing transformer. Okay. If it's not possible, so we are going to check another transformer which is near to the complex. Okay. So the transformer is 20 years old. Considering the hot summer, okay. So during the hot summer, we need to make sure that the transformer is not overload. It's suggested not to load it beyond 90%, okay, due to hot summer. The load of the commercial complex are, so there are 3 petrol pump, diesel pump, LNG pump, 5 horsepower, efficiency is 0.9. Install load is 5 kilowatt, fish and chip, connected load 5 kilowatt, 6 street lights, okay, 100 watt, diversity factor is 1.8, demand factor is 0.7, fish and chip shop 0.8, diversity factor of the whole load is 1.2. So we are going to calculate what is the coincident maximum demand of the whole complex, and we want to make sure, is it possible for this commercial complex to be connected to the existing distribution transformer? Because the existing distribution transformer has their own load connected to it. So we want to make sure that if we want to inject, if we want to supply for this complex, whether our transformer is still possible to supply the electricity. So first we have to calculate the total diversified demand. Okay, 5 pumps multiply with 5 horsepower. So we want to convert to kilowatt times 0.745 times the efficiency divide by the diversity factor, which is 1.8. Okay, we get 9.325 kilowatt. The peak demand of the general purpose shop, okay, so the shop is 5 kilowatt times the 0.7 is, okay, 0.7, that the demand factor, okay, the demand factor of the shop is 0.7. Fish and chip shop 4 kilowatt times 0.8, the demand factor. Okay, street lights is 0.1 kilowatt times 6. Okay, you have 6 street lights. Okay, and the peak demand is 0.1 kilowatt. So you have to sum all the individual maximum demand. You are going to get 16.625 kilowatt. And the coincident maximum demand is individual maximum demand divided by 1.2. Okay, what is 1.2? 1.2 is the diversity factor. Okay, diversity factor is 1.2. Okay, so we have to make sure, okay, that the power factor for the complex building, the commercial building, is not beyond 0.85. Okay, because when your power factor surcharge is below 0.85, what will happen to your company? Bukan bankrupt lagi. Bukan ringkup. TMB will penalize due to okay, definitely low power factor have higher loss. In Saudi, what is the electrical power company? Kahraba. Yes. National Saudi Electricity. Just like our in Malaysia. TNB. So they actually the same thing. For low power factor, they will have power factor surcharge or penalty. It means that the company must pay to the TNB. It is called as power factor surcharge. Denda faktor kuasa, kena bayar surcharge. So you have to make sure that the power factors is low, higher than 0.85. Means that 0.85, 86, the best is 1. Okay. Kemudian distribution transformer is not to be loaded beyond okay, apa maksud dia ni, student? Sekarang ni transformer tu dah tua dah. The transformer is 20 years old. Kemudian it cannot be loaded beyond 90%. It means that it can only be operate, okay, 0.9 times 310 kVA, which is the capacity of the distributed transformer is 279 kVA. So the existing capacity, nampak tak? The current maximum demand of the transformer is 250. So how many balance that we have? The capacity of the transformer is 279. So minus with the existing load connected to the transformer. So you have 29 kVA. 29 kVA. So boleh ke tak boleh ni student? Ha? Kenapa? Berapa kompleks tu punya maximum demand apa? Load tadi tu kamu ada fish and chip, shop, pump semua tadi tu total berapa load dia? 16. Kamu ni memang dah kenapa? 16 ke nak kira ni? 16. Ha? Astaghfirullahalazim. Eloklah kalau nak belajar ke tak nak belajar? Kalau tak nak belajar balik ni masak. 16. So balance lagi capacity of the transformer tu yang kamu boleh supply lagi 29. So okay, the reserve capacity for the transformer is 29. So the load of the complex that you are going to connect with the transformer is only 16. So it's still within the reserve capacity 29. Okay, if you inject or you are going to supply to the complex, so 250 plus 16, how many? 266, right? So it's still below than the maximum capacity of the transformer, which is 279. Allah Akbar. Application approved to the connect the existing distribution transformer. Faham dah ni? Soalan ni saya bagi masuk peksa pun kamu tahu. Aziz? Abdul Aziz, do you understand what I say? What did I say? Okay. Load forecasting. Okay, load forecasting ni penting lah. Why? Why we need to do the load forecasting? Planning, operation and control. Okay, we are going to estimate what is the load, active load at various load ahead of actual load occurrence. Okay, planning, load forecasting, certain lead time, forecasting interval. Okay, good forecast, reflect current, future trends, tempered with good judgment. Ni maksudnya with experience, you can have the good judgment. It's the key to planning, indeed to financial success. Okay, you have to make sure that this is the actual load, the blue one, this one is the load forecast. Because we don't want, we produce higher than the exact ataupun the actual load. Because definitely when we produce higher, it will be losses, kan? We know that the raw material the coal, kemudian gas, oil, semua tu is expensive. Okay, so we have to think economically. We have to make sure that any electricity that has been produced is being supplied to our load, and that is what the load required. Okay, alright. So I hope that you can understand what is the load forecasting. So what is the factors affecting the load forecast? Yang simple lah, kan? Nak forecast ni definitely population growth, kan? Industry, apa lagi, plan, city plans and so on. Okay, nak masuk renewable energy in future. Okay, so forecast ni very short term, medium term, long term, from few seconds to months or years. Okay, what is the forecast methodology? If you are going to do postdoc today, masters, research, we are going to study. There are so many methods for load forecasting. Extrapolation, correlation, neural network, deep learning, AI, whatsoever, semua. Okay. So actually we have also load growth. Okay, example of typical energy requirement projection for a certain country. Okay, if the load increase, if the load demand is increased, it is actually good or bad for the country? Yes, it's good for the country because we know that the country has economic growth. When the economic growth, it means that it needs more electricity. Okay, so for example, student in China, they are using terawatt, they are producing in terawatt. Sekarang kita pakai mega, giga. So you can imagine what size of the industry, okay, in China, in India, US, you name it. So student, actually the electricity consumption for a country that is modern is far better than third world country or poor country. Sedih lah, sedih. Ha? Are we poor?
No. Kita membangun.
Kita negara membangun lah. You know Madani? You know Anwar Ibrahim? Okay, never mind. Our Prime Minister Anwar Ibrahim. Okay. Mahathir, you know? Mahathir? Mahathir. Rosmah, you know Rosmah? Rosmah. Kalau tahu Rosmah lain macam. Kamu ni budak-budak.
Kamu boleh kena.
When I go for Hajj, I climb up to
What NDB?
Gua Nur.
Wait.
Naik Gua Nur. There is a person alongside the road. They said to me, Najib bagus.
Okay.
You know?
Betul Najib
I'm
bagus.
quite surprised because they also know Najib in Saudi. You know Najib? You don't know. Never mind. It's very good for you. You just study. But now the Prime Minister is Anwar Ibrahim. You should know. Okay? Tahir, you also don't know. My Prime Minister, Anwar Ibrahim. Next, Alif.
Wow.
Takut.
No Madani, no third world country. Allahu Akbar. Ada lawak kamu ni. Gurauan je lah. Jadikan kamu viral saya habis ya saya. Dia umur lah masa. Tak nak sekolah jadi supir. Okay. Growth rate, okay. We can calculate actually what is the growth rate of the electricity supply. Okay. if we double the time, what is the, we can calculate. Okay, what is the doubling time? Approximation equation, this is the peak demand. So, example of peak power demand for a certain country over several years. Okay, so the job, okay, the power system planners also need to know how much power will be demand. Definitely lah, because we want to make sure if we are going to expand the power system, what will be the power that we need. Okay, kita nak develop. Okay. Why this data is very important, student? Why this data is very important?
Sebab jarak.
For investors, yes, for investors, when they want to invest for this country, they know that we are going to have strong industries. Definitely, they will invest in our country to develop the electricity supply, because definitely we are going to use more electricity, right? And will bring definitely profit to them. The area under the curve is a measure of energy consumed during the period. So this is the power demand. So the area under the curve is the energy consumed in Q. Okay, this we can calculate what is the growth rate as well. Okay, so what is the, for this case is the growth rate is 4%. How many years the energy will be tripled? So by using the formula, we are going to get, okay, to 27.47 years, okay, the energy will be tripled, 30 tahun. So how to calculate? When the energy consumption is expected to be doubled in 10 years, the growth rate by using the formula, we are going to get the growth rate in 6.93%. Okay. For example, for load growth here, for one distribution transformer, it means that for one transformer, they can supply the primary feeder. You can supply up to 3. You can supply to up to 3 points. Okay, which is 3 feeders. The first feeder is 1,800 kilowatt, and then power factor is 0.95. And then the second feeder is 2,000 kilowatt, power factor is 0.85. The 3 feeder is 2,200 kilowatt, 0.9 power factor. Okay, so we are going to calculate 30-minute annual maximum demand, kilowatt and kVAR, load diversity, and make sure, calculate, determine which one of the transformer is suitable with the load. Okay, the company policy permit as much as 25% short time overload. Maksudnya, the company, is it permissible for the transformer to have 25% overload, for a very short period of time? Maksudnya boleh. Itu company punya requirement lah, satu guideline lah dia bagi. So dia nak cari berapa dia punya, how many years will be loaded to its fans on rating. It means that for 7,500 capacity, the transformer can be cooled by the air in the ambient, dengan udara biasa. And then when it reach to 9,375 kVA, the transformer will be cooled by fans on, by using fan which is attached to the transformer. This is what we call, what does it mean here? So the given diversity factor FD equals to 1.15. Sum of individual maximum demand here. How do we know here? This is feeder 1, feeder 2, feeder 3. Means that the transformer supply to this load. The first load is 1,800, 2,000 and 2,500. 200 kilowatt divided by DG. Okay, so DG is the coincident maximum demand. So the FD is the diversity factor. So you can calculate what is the diversity factor in kilowatt. 5,217.39 kilowatt. Okay, so this is the coincident the annual maximum demand DG, annual maximum demand DG in kilowatt. So what is the total reactive power, student? Okay, you know the power factor is given in the question, right? So you can calculate the angle. In order to calculate the reactive power, you have to multiply power with 10. Ingat belajar Sohca tua tu? Itulah rumusnya. You know Sohca tua? You don't know. You know trigonometry? Yes. Trigonometry means that in order to find your tan, you have to divide the you know how to calculate the so theta is here. Okay, this is your P, this is your P, this is your Q. So in order to find your Q here, so tan theta times P equals to Q. Okay, because tan theta equals to P divided by Q. Okay, very simple formula. Okay, and then from there you can find what is the total reactive power in kVAR, 2500. Okay, student, DG in kVA you are going to get 5793 kVA, the load diversity factor. How do you get here 6000? Dapat daripada mana, student? Nama ibu? Total power of the transformer ni, feeder 1, feeder 2. What is the demand? The maximum demand 1800, 1800, 2000, 200 and 200. So you got 6000. Okay, that's the 6000 kilowatt connected to the one distribution transformer. Okay, and then minus with the 5200 kilowatt that you have calculated here. Okay, this is the annual maximum demand. Okay, 5217. So you have the load diversity factor is 783 kilowatt. Okay, so the transformer size capacity, if permits 25% of short time overload, the maximum demand is 5793.60 kVA. So which one is nearest? Okay, if you have this type of transformer, the capacity when we can have 25% overload for a short period of time. So as compared to 3900, is it possible for the transformer to supply with our load the maximum demand? So it is undersized. So our maximum demand is 5793. For this type of transformer, it can provide 5855.75. So this one is the nearest. As compared to this, is oversized, 7000, 11000 also oversized. So the most suitable distribution transformer is this type, 3750, 3750, 460, 4687 kVA. Self-cool, forced air cool. Self-cool means that, okay, when it's 3750, the transformer can be cooled by the air in the ambient temperature, and if it reach the demand reached to 5,687, the fans connected to the transformer will turn on to cool down the transformer. Okay, so this is the type of the transformer. So actually it gives the advantage for the transformer. If reach the capacity, no need to install a new one. So we can we just have to install, turn on the fans so that it will cool down the transformer and the transformer can be working. No need to change for another transformer. So fans on mean force air cool. Bila kita nak pakai ni force air cool ni, so we can use this kind of transformer, and then within 7 years, okay, it reached to the fans on rating. So it will be loaded to its fans on rating in about 7 years. Okay. This is definition of power factor, student. So what does it mean by power factor? It's cos theta actually. How effectively the current is being converted into useful work output. Useful work output is in kVA, kVAR, kW. What is the useful? kW. So when you have lower power factor, okay, for example this one theta, this is P, this is S, this is Q, right? So for example this one is 0.65. It means that your S is more than your P. Definitely this one is losses, okay, due to your inductive loss, inductive load. Okay, so we want to make sure that the load, okay, is very low, the power factor is very low. We want to make sure that the power factor is very low, okay, so that, which is the power factor must be less than 0.85. So to make sure that what we generate in kVA is equal to the load, okay, is equal to the load. Okay, so actually like this, S will be equals to P with Q is lowest. Okay, so that's why this is very important. Like if you remember that I have told you, I don't know whether you remember or not, the Q is just like the bubbles in your teh tarik. Okay, is just losses. Okay, the only water that you drink is only the teh, right? So this is Q, the bubble is Q, the P is your water or teh, or maybe your Coke. Now you are boycotting Coke, Pepsi. Really you are boycotting Coke and Pepsi? Yeah. Minum lagi Coke or Pepsi? Okay, I don't know whether you are still drinking the Coke or Pepsi, whatever. But it's just, I just want to make the example. So the bubbles of your carbonated drinks is your Q. You can only drink the real water, which is P. But actually, the manufacturer of the carbonated drinks, they have to provide with the bubbles, right? Yeah. What happens if you drink the Pepsi and Coke without the bubbles? Is it okay? Do you like it? No. Definitely no, right? So I also like my teh tarik also with the bubbles. So the orang yang buat tu lah kena tarik juga lah kan. Padahal nak bubbles tu bukan minum pun, minum air tu je. Okay. You know teh tarik? You know teh tarik? The drinks ada store. You say I want to drink teh tarik. They have the tea, actually the milk tea. They have to pour to make sure you have bubbles on top of the tea. Okay? It's not very good because it's high sugar. But it's very nice. When it's cold, you know, raining, you eat teh tarik, very nice. Right now, you know, raining kan, very nice to eat teh tarik. Okay, student. So you have to make sure low power factor. So that because actually why? Because the generating station, our power station provide the Q, which is in kVA. So that will be the losses Q. That's why TMB want to control. This is your Q. Okay. 70 power factor, or this is the source. Okay. That produce the reactive power. Induction motor. Macam-macam lah. Aircon, pump, heater, blower, furnace, weaving machine, grinders, welders. Okay, when you have power factor 0.8, the losses is 1,500. The power factor 0.65, can you imagine what is the losses here? From 1.7, 1,005 watt to 2,200 watt when the power factor is below 0.8. Transformer. What happened to the transformer when your power factor is 0.45? The transformer loading is 77% of the loading. Kamu rasa transformer ni macam mana keadaan transformer ni? Overload. Apa jadi dengan transformer tu? Transformer when it's overload, pertama dia akan panas. Kalau overload sangat boleh apa? Transformer will explode, meletup. Okay, what will happen if the power factor is 0.9? The loading apa? Santai, 88% the transformer. So the capacity is 100. So the transformer loading is 88%. Okay. So reactive power on the transformer, low power factor increase the transformer loading. Okay. So what will happen, student? Below 0.85, you are going to penalized by TMB or any kahrobak company. So, you know kahrobak? Siapa faham masalah? Kahrobak tu elektrik lah. Right? Kahrobak elektrik. Kahrobak muhandis lah. You want to be kahrobak muhandis lah. Engineer elektrik. Okay, so above 0.85, what? Kamu tak nak kerja ni, Middle East. Kan? USD. I think the pay is in USD, right? For Saudi Aramco in Riyadh. Okay, so how to improve power factor, capacitor bank, corrector, synchronous generator, synchronous motor. Okay, student? So we can improve, reduce the kilowatt bill, eliminate the power factor surcharge. Because actually you are going to pay for nothing actually when you have the power factor surcharge. Increase the system capacity, reduce system losses, increase voltage level, resulting more efficient motors. Actually, when you have high power factor, your motors is actually will vibrate more. Vibrate more means that you are going to experience more power losses. Okay, so that's why we will inject capacitor bank and it will reduce your capacity, your S, and definitely okay, today I think I will stop here. Power factor for power factor correction table. Okay, selesai dah attendance. Okay, so do you have any question?